med students there, it's like don't, basically like almost no interaction with them. They're like, don't touch me, leave me alone. You're gonna cause my A right now to turn into a C just by that.
Yeah.
So,
By association.
yeah, by association. Yes, exactly.
Grades are contagious. Guys.
Yeah.
Oh gosh. Yeah. Yeah. No, pretty much that was it. No, thank you. Yeah. That's why I am not.
I get the attendance points. I'm out. I mean, it saw us there. It's like all the stuff and plus the stuff you could just learn.
I thought it was pretty bad formatting. Oh yeah. Actually, she would have like numbered the arrows and then add lines.
Yeah. But I mean also,
This is the one that I want.
it's good to at least have some sort of structure with it too.
Yeah, because then I like get to be doing actions. Which is kind of the problem. Like, yeah, you can learn or mess around, whatever, but I'm having like some assignments. Well, sometimes you don't pass. That's actually true. That's true.
It's like great. Yes. Yeah, what exactly? What should we do before? Yeah.
I also like this.
Yeah, you're right.
Yeah.
Yeah, that's why it's gonna be worth so much when I
These
sell it.
days, that's a lot of. That's kind of why it's a lot.
If it works, if it runs. If it doesn't, it's going to be.
School right now, and then I'll be able to teach myself. Even going back to school, be able to like learn whatever else I want to. I just need to get a job, and the real question is how society works.
You're still going for like one.
Yeah.
First is always the hardest.
How's that? You get any response back?
Yeah, I was the same way.
It's
I can't read his whole manual.
and that's like the initial application. That's like the document that's like.
No, it's the one I bought.
Request. Can you talk about this?
Yeah, I've bought like.
Or maybe in
Yeah.
Yeah, we can talk about it, but it also makes more sense when you have your data.
Okay. Oh, I do have data.
And then have you plotted it with Excel there? Because you want to slope.
Yeah, but then I.
Oh, it's easier to.
Yeah, so once we have a line equation, I can still talk about it, but it's just a lot easier to talk about.
Okay. So am I doing for the time? Am I doing the reciprocal, so 1 over the time? Or am I just doing 1 over time?
Yeah, because you just have regular time and then, yeah, 1 over S.
Oh, so it's not 1 over R, it's just R?
Yeah, well, time is equal to 1.
Oh, 1 over.
Yeah,
Oh,
because
it's
our max is going to be our y-intercept. Yeah, just for that plot yet. I think once you plot it, it'll start to make more sense, because once you plot it, yeah, you'll see the
Well, I
light
brought it
intersection,
together.
and then from there, right, then it's way.
And then I found out that I
Then you can
cracked
find your
it.
tan and your slope.
Okay, thank you.
I guarantee you there's gonna be, I guarantee you there's gonna be at least like 100 people. I guarantee you. That write that on their application, someone looks at it, denied instantly. I guarantee you, I guarantee you. It's like, okay. God. That must, they must have a program that looks through it, and if any mention anime comes up, just gone.
No,
I checked.
they'll major, okay? And so they'll be like, okay, you know, you don't even deal with anime?
No.
You're gone. Like if they're getting into like, say, Digimon or whatnot, you're like,
And like, there wasn't even,
I don't know.
you know, basically, how many times, I was just like, time are you willing to be
No, no, that is heavy. It's just like, okay, how much free time do you
and
want?
then she
No. Yeah, you don't want that, actually. What are you doing? Years of business meeting.
receiving the arrows.
Nah.
But it was weird.
Okay.
I like some.
Well, I mean, it's like any other show, like, do I like every show? No. But some, like, of course. I appreciate the word fit.
I appreciate.
They can just go too far. And then it gets to the point where it's just, like, because, I don't remember when the study was done, but there was a study
It's been in my
that related
stepdad's name.
countries'
I
like
went to one in
productivity
2 years.
in
I got
terms
the
of
paper
like
sitting on my
hours
dresser.
worked.
No one's paper sitting on. No one's told me what to do with it.
Because they
No one's told me what to do with the paper. They're just like, yeah, I'll help you. Yeah, I was like, okay. That's my parents.
like the dumb business leaders that want to do the
I know.
things that are like, oh, you have to stay in even if, like, when your superiors are still
I had my taxes back for months because no one would, like, my stepdad wouldn't sign the paper to like let me do it myself.
doing anything there. But you still have to, because
Okay.
it's like culturally
I was like, oh, I got super pissed. I was like,
and
really?
like
Been waiting for months.
like people will
Didn't know why I couldn't
like
get
prick if you stay in order whether you're doing any work or actually work. You're like, oh great, you're hard at work.
You know,
Not really, you're just kind of there. But then you have to know. No, yeah, no, it's truly, you know, drive to sleep, go home, have something that makes you want to enjoy life. Maybe have a family, I don't know, do what you want, but you should be able to have enough time to decide.
So if you're on.
Like, I respect the grind, but there's a limit, there's a higher limit to the grind state.
There's high food. It's like putting. Just don't understand. I'm a much perfectionist. That's why you don't have to work
Like the grass was so cool. And I thought.
All right, let's go ahead and get started. So just a couple of things. I've caught up on grading, so I have a fat stack to give back to you. So check your grades, make sure everything's accurate. I've also gone through and checked out your paper submissions, at least those of you who have submitted them or at least submitted something. So that's all I was really looking for, was kind of something. And if you haven't submitted something, you need to do that ASAP just so you'll be on track. And I would at least say, right, look at those journal articles and kind of start figuring out where you want to take your story. And even those, who did submit something to me, I left some comments, and we can always talk, in lab or after class, or we can make an appointment, whatever. But everyone seems to be off to a good start, at least that submitted something, so I like all the different topics. And then just looking towards our goal to have our draft of our paper. So 5 pages will be the final. I will accept 3 for our draft, just in case we don't get there. So I understand it's a work in progress, and so just talk to me. All right, let's actually talk about the lab for a little bit, at least this part, since I think there's some confusion. And let me show the equation again too. So the first part was deconvoluting what they wanted you to do here. And so what they were trying to lead you through is converting, your drops to milliliters. Maybe I should have put the whole lab on there. Let me pull this up. So and if you haven't done the lab, you can kind of see what you'll be doing. So you had your part B, where you were figuring out how much urease to use. And so this was the kind of suggested starting point. And we didn't change our drops of urea, so that's what it's referring to, our 1, 2, 3, 4, 5 drops. So then for the data table, and we could put this in, so 1, 2, 3, 4, 5. And then what it's trying to get you to do is convert this volume to milliliters, So it said that 1 milliliter was 22 drops. And if you wanted to, you could, of course, leave it in drops, and then you multiply all your milliliters times 22. But that's what it was going for, so 1 over 22, 2 over 22, etc. And so kind of the point, though, is we're trying to get to S, And so what it was saying, well, we had urea that was prepared originally as a 0.6 weight per volume solution, and then it had you calculate the molarity, as part of your pre-lab question. And so then that's just your molarity here from your pre-lab. And we can also go over this if people want. And then all it's trying to do is get you to do that dilution calculation. So C1 V1 equals to C2 V2. So we care about C2, or S, for our calculations, since we have to graph 1 over S. So to get that, that's what they're leading us to. So we started with our original concentration, then do the dilution, and of course, with your V2, you have to add up all the volume of everything, again, as best you can, in either drops or milliliters. And then you find your new concentration. So I'll just say it, this is basically new urea concentration based upon how many drops. And then, then you plot your graph. So let's kind of talk about your graph some more. But I think your graph will start to make more sense once you actually plot it. Sorry, too many windows. So then it says, plot your graph. So we have time on the y-axis and 1 over s on the x. And so my suggestion was to use Excel, even though they provided a graph. I would still use Excel so we can get the numbers, and that'll make it a lot easier for you instead of, trying to take the ruler and measure. That's no good. So then you'll have time, and then 1 over s, and so you should get a line. And then they were saying, so your y-intercept is your R max. so y intersects is 1 over r max, right? And then you can use that value to figure out your km. So you're trying to figure out km, and then you're plotting, and so you can kind of rewrite this, right? So our general form of any equation, I'll just rewrite this equation. And to write any equation has your form y equals mx plus b, where your slope, right, is m. So then you're plotting x, so that's just 1 over s, right? So just see how that translates. So then your slope, so slope is km over r max. But then like we said, our y-intercept was 1 over r max, so then we can solve for km. And so, right, the nice thing is you'll use Excel, it'll spit out your line equation in this y equals mx plus b form, and then you can plug it all in. But like I said, if you need help with this, just ask me, but I would, again, plot it first, get your line equation, and then we can work through it. Does that kind of help maybe clarify that last section? And yeah, just trying to see what they were trying to do, I think, was the hardest part in all that. All right, so let's go back over here. And so let's just warm up with this problem, see if we remember the terminology and what it's asking for. So it says chlorine trifluoride is used to prepare uranium hexafluoride, which is used for separating out uranium isotopes. And so it says chlorine trifluoride is prepared by this reaction. So 1 equivalent of chlorine plus 3 equivalents of fluorine make 2 equivalents of chlorine trifluoride. And so it asks for write the equation that relates the rate expressions for the reactions in terms of the disappearance of chlorine and fluorine and the formation of our product. What is it asking? And then make sure you check the board. I have 2 homeless assignments. I'm not sure. It's a chapter 15 and chapter 16 homework. So what is this asking for? What is our rate expression? What's rate again? All right, so I'll repeat what Alera said in case you didn't hear. So rate, we're just measuring our change in concentration, right, over some time expression. And so what is that telling us? And what can we say about this rate and their kind of relative rates? What do we remember from the expression? Maybe we should go back to the graph. Remember this graph here, what we were saying? So what was the key here? What do we notice about the rate? How do we express just that instantaneous rate? And how do we relate them to each other? What was the key there? Yeah, so did everyone hear that? So your fluoride disappears 3 times as fast compared to your chloride, right? Because they're in a 1:3 ratio. And then we're also saying, so our chlorine trifluoride, right, appears at a rate as 2 times as fast. So then how do we write those expressions? And we can go back to the notes for a second. So remember this little note, how it said we had to divide by the coefficient then to kind of make those rates equal. Oh, sorry, going everywhere. And so then what do we get for our rate expression? So how do we write our rate? Let's just start for chlorine. What does that rate look like? Yep, so 1/1, and then we'll put negative since we're relating disappearance to reappearance. So that looks good. And then what about our rate of fluorine then? So now 1/3 times our change in time. And so what does that lead us for our chlorine trifluoride? So now, and then plus 1/2 for chlorine trifluoride. All right, good. So that was just kind of definitions and remembering what this rate expression meant. All right, other questions on this one? Let's try another one. So now let's examine this equation. So it says we have this process here. So carbon monoxide as a gas plus nitrogen dioxide as a gas gives you carbon dioxide gas and NO as a gas. So if the rate law for the expression is given here, so rate is K times the concentration of NO2 squared, then what is the effect of the following two? So A, decreasing the pressure. So what happens from 0.5 atm to 0.25? And then B, what happens if we increase the concentration of CO? So I'll give y'all a few minutes to look at that. So what do we think about A? So what happens if we decrease our pressure? Excellent. So right, did everybody see that? I'll repeat. So right, we went by half here, but then if our factor is squared, then we're really decreasing by a pressure of by a factor of 1/4 for our reaction rate. Excellent. And then what about B? So what happens if we increase the concentration of CO?
I think because there's no CO in the reaction rate equation at all, then it's not related to the reaction rate, and so it just it's a zero order.
Excellent. So CO, 0 order, so no effect. Excellent job on those. Questions about this one? Anything?
Just trying to remember exactly how the pressure is related to rates.
But you can kind of think of pressure and molarity as just like different ways to express concentration. So in gases, right, we use pressure. Molarity obviously is for solutions, but yeah, it's the same way.
Oh, gotcha. Okay, that makes sense. Yeah, I was thinking that, and I was thinking of like differences between like say pressure, like say moles and whatnot. Like,
Yeah.
how's
Yeah, it'd be the same. So we had put like 0.5 moles to 0.25 moles, right?
so
Then-
basically it's just say we're just equivalent it to the amount of what our whatever substances in there.
Yeah. All right, let's try this problem. And so regular flights of supersonic aircraft in the stratosphere are of concern because they say these aircrafts produce nitric oxide. And so this nitric oxide can react with ozone. And so this has been suggested. It could be depleting the ozone layer. And so it says that our reaction, so our NO plus ozone gives us nitrogen dioxide plus oxygen. And so they say it's first order with respect to both NO and ozone with a rate constant of 2.20 times 10 to the 7th liters per moles per second. So what is the instantaneous rate of disappearance when your initial NO concentration is 3.3 times 10 to the negative 6 molarity, and ozone is 5.9 times 10 to the negative 7th molarity. How's our problem coming along? So what have we set up as our kind of rate expression? Yeah, so did everybody get this right? So this is your rate expression, and again, going with the first order, so first step, and then, yeah, we just have to calculate it because it's asking for instantaneous rate, so at these points, they gave us our rate constant, so now we can just plug it in, and so you can tell me what you got. Liters, second, so 3.3. And I'm just writing out what molarity is so we can see our units a little bit better, since these get a little confusing. So moles per liter. So these cancel, that one cancels. So now we're left with moles liter seconds. And does someone want to tell me a number while I pull up my calculator? Or? Yeah, it should be molarity per second. So 4.28. And then was there a power on? Times 10 to the negative fifth. And so it should be molarity second. So is that what everybody else got for their answer? Okay. I won't punch that in unless anyone needs it shown. Yep, that's my plan. All right, let's do another practice problem. And so now let's look at this scenario. Oops. So we have nitrosyl chloride decomposes to NO and chlorine. And so we're given this expression here. So 2 equivalents of nitrosyl chloride give us 2 equivalents of NO and chlorine. And so from this information, determine the rate law, rate constant, and overall order. So I'll give y'all some time. Yeah, it's a subscript. Let me fix it. Oops. Oh, yeah, the cheat sheets?
Yes.
Let me see.
I was not here on Tuesday.
It should be somewhere. What did I do with them all? Oh, here they are.
Thank you.
You're welcome. So how are we doing on this problem? Do we figure out maybe the order? So where do we start with this?
So what I did to try to find the order is, because it's just nitrous chloride, that's the only reaction I'm doing, is that for our reaction equation. And since we have different variables, concentration and rate, we can set up the equation in three different points. But before doing that, what I did is I just divided the rate by the concentration, and then I multiplied by one times the 9, and just together nice numbers, and it was showing us values that for the rates jumped up linearly. It's a first order concentration numbers with it. Yeah.
First order? I'm not sure. I followed at the end. Because what happens, what if we just compare like these two rates? Because your concentration of nitrosyl chloride doubled, right? But then what happened to your rate? Yeah, so then this should be times 4. And then we could compare, because this isn't as nice, but we could jump from 0.1 to 0.3. And then let me pull up my calculator. Oh, so 9. And so with those two, oops, that was a really bad 9. So with those two pieces of information, yeah, I got second order for our nitrosyl chloride. Is that what other people got? I see. And so then what do we do with this expression? So we have our order. So now what? So now we need to figure out our rate constant. And we were given rate. So did you just plug in? So I guess we could set up rate equals our constant then times our nitrosyl chloride. And then did you just pick a value to plug in? Any preference of which one you picked? So I'll just pick the first one. 0.1 is always an easy number. So let's see, we have 8 times 10 to the negative 10th is equal to K times 0.1 squared. And so now we just need to solve. So 8 times 10 to the negative 10 divided by 0.1 squared. So did we get that for our K? So I see thumbs up for that. So K would be 8.0 times 10 to the negative 8, and so liters, moles, hour. Questions about this one? All right, let's try, actually, let's look at a homework one. So let's try this homework problem number 4. So this could be tricky. So we're looking at 2 equivalents of NO again plus fluorine gives us nitrosyl fluoride. And so see if you can figure out the rate for that one. So determine the rate law. How's this problem coming along? Did we determine what orders the NO and fluorine were?
Yeah, I believe the NO was second order, and then the fluorine was first order.
Is that what people got? And so how do we come up with that conclusion? So, okay, so we said NO squared and first order for fluorine. So what do we look at?
In like an isolated, the differences between each variable, if you look at which one doesn't change,
Excellent. So that looks good there. Any questions on that one? All right, let's go back to the random questions. So now we'll try another one, or these rate laws. And so now we have nitrogen monoxide reacts with chlorine according to this equation, so pretty similar. Let's see if it's the same. So what are the rate laws? And so see if you can find the rate constant and the orders for this problem. Unintentionally, this was pretty similar to your homework one.
Every time we see NO, second order.
Yeah, when NO is like in so many of these problems. Yeah, and well, NO, you can tell, right? Odd number of electrons, so it's going to be doing funky stuff all the time. And so let's see. So we examine this again. And so we can double our NO. And so this was 4 times our rate. And the same thing for chlorine. So now this doubles. And this was times 2. So we probably got something similar to our homework of second order NO and first order chlorine. And so what do you get for the rate constant?
You can just plug in 1 squared times 1 equals n, and get the rate equals 9.1.
I like that. So easy math is smart. Oops. So I like that. So 9.12. Polarity per hour is equal to 1 squared. So yes, get 9.12. Oh, that should be squared though. any questions about that one. And so for fun, you could compare once you get number 5 in your homework, you could compare their rates. Just note that this one was given in hours, and your homework was seconds when you look at that when you're bored. All right, do we feel like we have enough practice on this? Feel better about this? This side of the room's kind of quiet. You want to do one more? Let's do another one. And this time, oh wait, NO's still in there, sorry. NO always comes back to haunt us. You know, now I'm curious with your second order theory, so let's test that. So now we're looking at hydrogen reacting with 2 equivalents of NO to give us N2O, and water, so that's forming laughing gas. So determine the rate law, rate constant, and orders once again. Hopefully that's large enough. So what do we find for our orders for our problem? So did you prove your theory correct?
My theory was in fact correct, and I know was once again, second.
That's pretty interesting. I'm not sure what this is telling us, but yeah, I agree. So we looked at this. So this doubled, and then this quadrupled, which I was punching on my calculator off to the side. So there's the by 4. I couldn't do that one. And so yes, we got NO was second order. And then what do we get for hydrogen? So then we can compare these two. So then we all got first for hydrogen, so that sounds good. And so now we can rewrite this. So rate is equal to K times our expression here. And let's see, none of these numbers really speak to me. I might just pick the first value. You guys can tell me something else. So something like that. And so what do we get for K?
I got 0.0.
So is that what everybody else got? Just punching it in for, yeah, so I get that. Any questions about that problem? So feeling better about these? The different types of problems that we can see, so either using, and then everyone has the cheat sheet, right? So make sure you get the cheat sheet, so kind of our radioactivity cheat sheet, and then our handy equations on the back. All right.
On the test, you gotta make the good problem where I know is first order.
Yeah, that's what I was thinking. All right, so like I promised, the quiz is going to be collaborative or homework, so you can take it home if you want. And then I would, take this time to ask questions, get help on anything that you need. So I'll be floating around, and then otherwise, right, you can work with your neighbor on the quiz. And if you're really pressed for time, obviously you can leave. But I would encourage you to stay, ask about your paper if you need, just whatever you need help with. And so the quiz team, feel free to get it back on Tuesday. Like I said, if you want to take it home. What?
I'll be at home, I'm like, oh yeah.
Yeah, I think so. I was trying to think about myself. So I think you're right. I was kind of thinking that myself, but I get confused if I don't really write it out. And then any questions? Oh, got this. Perfect. I will look over it and then we can chat.
Thank you.